So before we do factor by grouping, let's review all the ways of factoring. So far, what was our first method? We've learned many ways of factoring. Raise your hand. Yes, what's the first method? GCF is correct. So remember, when you have GCF, you want to make your life easier, make sure if you see any kind of factoring problem, you factor out your GCF first. Okay, that's going to help you a lot, right? If you don't do that, right, Stefan? That's going to really be helpful. Okay, then what's the next method that we learn of factoring? Anybody? Come on. After we do GCF, yes, Austin. Prime factorization. That's just for numbers and stuff like that. But I'm talking about for polynomials. Eddie? Factor. Yeah, that's what he's saying. That's prime factorization. Yeah. Difference of squares. You guys remember this? What does the difference of square look like? First of all, how many terms does difference of square have? Yes? One term? Difference of square? Two terms. And what kind of symbol do you have in the middle? Yeah. Difference, subtraction. That's why it's called difference of square. And then, of course, the first and the last terms are squared. That's why it's called difference of square. How does this factor? If I have a squared minus b squared, one person remembers? Come on, everyone should know how to. Yes, sir. Thank you. A minus b times a plus b is correct. I did a plus b first. Does it matter? No. Okay, what's the third method we learned how to factor? Now doesn't have to be two terms. It doesn't have to be binomial. Yes. Not yet. We haven't learned perfect. After this we learned, before learning perfect squares, we learned. Yeah. I think you're almost there. You're right. What was the thing that we learned? This was the easiest trinomials to factor. You guys remember? Why was this trinomial easy? Because yes, Sarah. Oh, that was the difference of square. The middle terms canceling out is the difference of square. Remember? You guys don't remember really? Like that's the easiest. Yes. No, that's later. We learn that later. No one remembers. Yes. Ax squared plus bx plus c. But this one was a special because this was the easy one. Your a was 1. Remember that one? Okay, you guys remember? Maybe you forgot because it was so easy. I don't know. Yeah, you're right. And then so what does this look like when you have 1 x squared plus bx plus c? This factors as? Yes, sir? X plus some number times x minus. You have to have x in there. Remember? We knew there was going to be 1x, right? Remember? So we did the cross, right? We did this. Remember, guys? Hello?
Yeah, I remember.
All right. Now, what's the fourth method we learned of factor? What's this fourth way? So does the a have to be 1 anymore? No. It just has to be a, right? Okay. So then we do what? Just ax squared. Remember this? Whoops. Let me hide the answer. So this is, a doesn't have to be 1 anymore. What does this factor to when you factor? Well, it looks something like this, right? Some number x plus some number times some number. Remember? We did this? Yes? And remember I gave you a big what? What was the big hint for this type of question? The book likes to give you, not every time, but Alvin? Huh? All right, exactly. If this was 10x squared or something, do you want to try 10x and x first or 2x and 5x first? 2x and 5x. You want to try the one that's closer together. Remember, that's a big hint, right? They like to give you those a lot. Okay, and that's it. That's all the ways of factoring. There's no other ways, really. Now, we talked about some special cases. You guys remember some special cases? Somebody mentioned, well, didn't we talk about where the c was negative and so forth? Well, that's kind of same thing as this, really. Isn't that right? So that wasn't really the... But what's another special case for this? When you have this trinomial, we talked about something called... Yes? Perfect square trinomial. And it is this type. Remember I told you we don't really have to talk about it specifically because it's part of this type. If you know how to do this, you know how to do perfect square trinomial, right? But what did the perfect square trinomial look like in terms of a trinomial? Anybody? Remember? Perfect square trinomial. Okay, first let's start with, okay, when you have perfect square trinomial, what does it factor to? How do we get perfect square trinomial? Perfect square, hint, hint. How do we get, you guys remember this? Yes, Aaron? Yeah, a plus b squared. Let's do it the other way. A plus b squared, isn't that right? So, remember we talked about, hold on a second. So, remember perfect square trinomial, we called it PST. Perfect square trinomial factors as how? In other words, remember this? Always factors to a? No, not always. No. Perfect square trinomial always factors to, remember this was a fact that we learned. One person remembers, I kind of even showed you the answer. Just, that's good. Then that makes you think about that one. Remember? Aaron already told us, really. Yes, Stefan. A plus b, what's that called? Yes. Square of a binomial. Remember? Squares of binomial. You guys remember that? So for example, so it's easier going the other way, right? So let me move it up a little bit. So PST, it always factors to squares of binomial. You guys remember? So if I have a plus b squared, just like Aaron said, what does that look like when you multiply that out? Remember, we learned this pattern. That trinomial must look like what? Yeah, this is a special type. I even called it 4.2, right? Because that's like, you know, really the fourth way of factoring. Ax squared plus bx plus c. But yeah, what does that trinomial look like? Thank you, Chris. Excellent. A squared plus 2ab plus b squared. Remember, we get the two of the same terms in the middle? Remember that one? And what about if I have a minus b squared? Because you don't have to have a plus b squared all the time. How's that look a little bit different, doesn't it? Yes, sir. Question? I mean, answer? Yeah, answer? Yeah, this time you get minus 2ab, right? Instead of 2ab. Does that make sense? Hello, you guys remember? So if you have a, okay, if you have a trinomial that looks like this, right? You get a squares of binomial. Okay, write this down. So what I want you to understand is that this, right, is really nothing more than special case for what? Ax squared plus what, guys? Bx plus c, isn't that right? It's just a special case. That's why I called it 4.2. Does that make sense? It's really under force. If you really think about it, even the difference of squares is this form, isn't it? How so? Because Leah already told us, remember? Isn't this kind of like the difference of squares too still? Because difference of squares when b happens to be what? No. Look at difference of square, guys. How is this form really covers everything that we learned so far, except for GCF, right? How is it that this covers, how is this really the difference of square also? Because b happens to be now, yeah, 0. You don't have the middle term. Right? And the first two and the last term are squared, and you have subtraction in the middle. So it really is this form, isn't it? Anyway, okay. So that's what we learned so far. Everybody okay with this? Are we good, guys? I think it's a good review, right? Okay. So this form, guys, if you know how to do this form, you can really do everything that we've learned so far. Isn't that right? It covers everything. Hello? You don't believe me? Do you not believe me? Okay, watch this. For difference of square, let's do one. Like, I don't know, 2, no, not 2. How about x squared minus 4, right? Isn't this x squared minus 2 squared, right? So let's do it as if we had this form. We could do x. Is that the only way to get x? Let's make it more interesting. Make it 4. If this is 4, what do you need here? 2 and 2. Guess what? Plus, what do we need? How do we get negative 4? How many ways are there to get negative 4? Negative 4. 2. Which one? 1, 4, or 2, 2. One of them has to be negative, right? Which one has to be negative? And which one works? Negative 2 and positive 2. See? We could use the same method for this, for difference of square. Still, it still works, doesn't it? Because look at when you do this, don't you get 4x squared? What? Here, plus 4x. Here, what do you get? Minus 4x. Here, what do you get? Oops. Minus 4. Checks. Checks. What do you get here? This happens to be 0. Checks. You see? The middle term is 0. That's why. You see what I'm talking about? So this form really covers all the stuff we've learned so far. Isn't that right? This is the most powerful way, right, that we learned so far. Are we good? All right. So example 1. Now factor by grouping is our new topic for today. And if I give you something like this is nothing more than we've actually dealt with this before, haven't we? Right? What is this, guys? How do you factor this? You could factor this by using, yes sir? Yeah, GCF. So factor by grouping is really nothing more than using GCF. Okay? Does that make sense? So, but I'll tell you why it's not just simple GCF. Okay? So when you factor out your GCF for this one, which happens to be x, who could tell me what I get here? Michael, what do I get? When I factor out the x, I get. Do you see my factor? Common factor, x and x. So I get x times what? X times what gives you 5w plus w? I mean 5x plus wx. You get x times 5 what? Plus w. Isn't that right? You see what I mean? Like, you know, you can factor it out. It's kind of like the distributive property backwards. Remember that? That's how. Remember GCF? Okay, good. Now let me make it more interesting. Instead of just giving you x, does it have to be x all the time? Could I substitute something else for that x? Well, this time I substituted in x plus y. Is that okay? Here, 5 times x plus y plus w times x plus y. Now, does that make it any harder? No, same thing. So, who could tell me how to do this one here? How about Ben? Yeah, well, don't you write the GCF first? Let's write the GCF first. What's our GCF here? X plus y. So x plus y times. That's exactly right. Do you get the idea? Right? Michael, does that make sense? All right, Michael, watch this now. This is the same thing now. Instead of x plus y, could I substitute that in for something else too? I'm gonna plug this in. Is that okay? Could it be a trinomial? Yeah, it doesn't really make any difference. Michael, what do you think this factors to then? This time my GCF is a plus b plus c, so a plus b plus c times 5 plus w is exactly right. Does that make sense? Because that's your GCF. If you don't believe me, multiply, like distribute it back in, you see? Then don't we get the same thing before? But this time it's factor, you see, it's written as a product. Very good. Does that make sense? So, do you think your homework will be this simple? Kind of. They get a little bit more creative, but not too much. Not too much. Okay, not too much. So write this down. A let me erase that. Helpful tool when factoring, when grouping. Well, when factoring. That's right. When factoring. Helpful tool is recognizing factors that are opposite of each other. Is that easy to recognize? How do you know something is opposite of something else? Like, for example, what's opposite of 7? Negative 7, right? How do you know if something is opposite of something else? Hello? Oh, you writing this down? Let me give you a hint. Let me give you more time. Go ahead, write it down. Let me ask that again. So when factoring, it's helpful to recognize factors that are opposite of each other, okay? So let me show you how. Here's what I mean by this, okay? So let me show you how they get more kind of interesting. But by the way, I like this example a lot. What's negative 3 equal to? Can I just multiply negative 3 by negative 1 and say, oh, negative 3 is equal to 3?